Hello students, welcome back. And I have done I think everybody has done their homework. Okay. So is matter around us pure? That is the chapter we are dealing with right now. We have so far done, talked about homogeneous mixture, heterogeneous mixture. We have talked about solution, solute, solvent, and concentration. Now coming to the topic of suspensions and colloids. So these comes under a heterogeneous mixture. Okay, so we are going to see their properties and differences. So where do suspensions and colloids fit? This I have already mentioned, in previous sections. Again, we are going to tell you that mixtures are basically, it is made, it is of basically two types, homogeneous and heterogeneous. Okay, so homogeneous mixture that has a uniform composition that we have been talking about for a very long time. An example would be solution. Under solution, you can see several other examples in your day-to-day life. Now coming to the heterogeneous mixture. So this should be actually made like, this is the first and this one is the second. Colloid shouldn't go under this, okay? We can imagine it as like this, suspension and colloids, okay? Now, suspension and colloids, both of them come under heterogeneous mixture. There are several reasons because their size, the particle size, is actually bigger than the solutions, okay, the solute size, okay, here. And also you'll see several other properties of them. So we are going to dive exactly into that now to study more about it. Heterogeneous, homogeneous mixture, we have discussed this earlier, right? So I'm not going to go in depths of it because these are super well mixed mixture. We know that, right? And here it is a little bit like these look a little bit similar, but their particles have different ideas or sizes, okay, about settling down. That we'll see. The difference between the suspension and colloids we'll see. Okay. Right. So moving ahead to the first topic of today, that is what exactly a suspension is. A suspension is a heterogeneous mixture where solid particles are visible and they settle down if left undisturbed. Okay, so it is a heterogeneous mixture. We are pretty sure about it, where the solid particles, okay, the particles which are made up of solid. Now you have pretty good idea about how solid particles are. Okay, they are visible to our eyes and they settle down if left undisturbed. Now you can imagine the example of soil and water, right? So sand in water, soil in water, or maybe muddy water, chalk powder in water, even that if you might have done ever, we used to do a lot. Okay, so in water, if you are adding these particles, actually these particles are much bigger, and they are what exactly is happening here, I'll tell you. So the water molecules are like this, right? And these particles are so big that they are not getting enough space to get dissolved and disappear in between water. Okay, so they are bigger than water, these intermolecular spaces of water. So that's why they end up settling down at the bottom of the jar or the beaker or the container which you have taken. Okay, so this is a suspension. Now, the properties of suspension. So we know they are unsettling mixture. They are not going to settle for less. Okay. So their appearance would be cloudy and non-uniform because we know that particles are a little bit bigger in size, right? So that will make the whole, you can say the solution, or not exactly, solution would be not a good word. Let's say mixture. So the whole mixture, the heterogeneous mixture would be cloudy. Okay. Like a winter fog on a busy street. Now, the visibility, if we talk about, you can totally see them with your naked eyes. So the particles present in that mixture, right? You will be able to see it with naked eyes because again, the size particle is big. Now, I'll tell you this one later. Now, coming to the particle size. So these are quite large, okay? Around more than 100 nanometers. So if you remember, solution particle size, it was around 1 nanometer, right? Or maybe smaller than that. But here, the particle size is 100 nanometer or more than that. So that is big enough to throw a visible shadow. Okay, so if you turn on a light, maybe like here is your solution, here is this mud settling down here. Okay, and this is, let's say, water. Okay, so if you pass a light from here, this will make a shadow here, like this. Okay. So this is it. Now stability, they are unstable. So once, if you'll stir it again, they'll again start moving, right? But they try to settle. They love to settle and take a nap at the bottom. Okay, you can imagine it like that. Coming to filtration, obviously the size particle is bigger. So you will be able to separate them maybe with a filter paper or something. So when you will pour water to it, the sand particle will remain here and then water will be filtered out, right? And Tyndall effect. So Tyndall effect is basically when you pass a light through any kind of mixture. Okay, what happens, since the particle size is big, no, the light will hit these particles and bend around like this. Okay, they'll bend, and it'll just look like, if in parties you might have seen the crystal balls or the lightings, right? So in those lightings you might have seen the disco balls and everything. So what happens is light goes here and there, keeps scattering here and there, right? So similarly in Tyndall effect also, the light gets scattered. Okay, again Tyndall effect would be taken in depth in the classes. Now coming to the colloid. So what exactly a colloid is? What exactly a colloid mixture is? Okay, so colloid is again a heterogeneous mixture. We know heterogeneous mixture again can be of two types, suspension and colloids. So colloids are heterogeneous mixture where the particles are evenly spread and do not settle down. In solutions, particles were getting disappeared throughout, right? And we are not able to see them with naked eyes, and they were uniformly distributed. In suspensions, if we talk about suspensions, you will notice that the solute, or not exactly solute, you will say the particles will settle down. Okay, but here what happens, the particles do not settle down, they keep hanging around in the phase, which is dispersed phase. Okay, you will discuss more about dispersed phase later in the regular lectures. Okay, so think of milk, it looks like smooth and uniform, right? You are unable to distinguish, okay, this is protein in milk. It's not like protein is going to settle down at the bottom. Sorry, let me just go back. Okay. Right, yeah, I'm able to draw now. Okay, so here the milk is able to settle down, right? So now just a second. Okay, let me just, is it, why isn't it working? Okay, yeah, okay, resuming again. So here it's not like the protein is going to settle down here at the bottom of the milk, right? It isn't the case. Okay, so that is why we keep it under the milk under a very different category, that is colloid. Now for example, milk, fog, butter, paint. Okay, these all are colloids, even though you think butter is a solid, or maybe paint turns into solid later, right? So there can be dispersed phase, different phases of it. It doesn't have to be a liquid only to be a colloid. Okay, it can be a solid also, a gas also, right? So here, fog, butter, paint, milk, all these are examples of colloid. And when you will pass the light through these things, they will start scattering the light in different direction. Even in a foggy day, you'll see when the light, the light comes, so it starts scattering like this, right? So we'll again discuss about it in detail. Okay, so the properties here would be the colloids look homogeneous. They'll give you appearance of homogeneous. They look like a solution to you, but they are not. Don't get fooled by it, okay? They are heterogeneous mixture, okay? Visibility, if we talk about, you can't see these particles with your naked eyes. They are too tiny, okay? So here also particle size is just like solutions, okay? So particle size are there, just the right size, medium, that is 1 to 100 nanometer. So if you remember in solutions, it was 1 nanometer, right? In suspensions, it was, 100, more than you can say 100 nanometer. And in colloids, you can compare the particle size. So it is 1 to 100 nanometer. Like that means in between that. Okay. Small enough to hide, but big enough to just, make it cloudy. Okay. Now stability. They are super, super stable. They are not going to settle, right? And again, you mix it. They are not going to be mixed. They are just, uniformly staying there. Their particles are loyal friends. They do not settle ever. Like, okay. Now, filtration. They can't separate them by simple filtration. Imagine a milk. Can you take out protein by filtering it? No, right? You have to do a centrifugation method. This is a very, cool technique. We used to do it in our labs, okay, during graduation. I hope you will also be doing it soon. So, centrifugation is something like where in tubes, we keep our samples and then we rotate at a very high speed. Okay, this whole centrifugation, centrifuge is the name of the, you can say, this instrument. So this starts moving at a very, very high speed. Okay, and that makes it, makes different particles settle down at different level according to their density. Okay. And that's how, like, here maybe proteins, here maybe something else is settling. Okay, so then you can separate it out. Tyndall effect, coming to the last one. So they show Tyndall effect. Suspensions, only some of the suspensions show Tyndall effect. But here, colloids show, like almost all colloids show Tyndall effect. So if you'll take, maybe milk or something, so light will get scattered if you'll pass light through it, because it is hitting the small, small particles here, tiny particles, and moving in different directions. Okay, so I hope this is clear. Now the differences you can see. So quickly we'll go through this, even though I have like explained this quite a few times. So the appearance, if we talk about, solutions are transparent. Okay, you can see through them. Imagine a lemonade. Okay, colloid appears uniform but is heterogeneous. Imagine milk here now. Suspension, cloudy, non-uniform. Imagine mud water, or maybe soil water, sandy water. Okay, now particle size we just now discussed, right? For solutions, it is less than 1 nanometer. For colloids, it is somewhere between 1 to 100 nanometer. Different colloids can have different, particle size. Coming to suspensions, it is more than 100 nanometer. If we talk about visibility, solutions not visible, okay? Colloids not visible, suspensions are visible. You can see through your naked eyes. Tyndall effect. So in solutions, there is no Tyndall effect. In colloids, yes, it is. And in suspension, some of the suspension, mixtures show the Tyndall effect. Some of it doesn't. Stability. So solutions are very stable. Colloids are stable. Suspension is not so stable. Okay, it is unstable. It gets settled down over time. It keeps on settling down. Okay, and when you stir it again, it gets disturbed. Now filtration. Solutions cannot be filtered. Colloids cannot be filtered by a normal filter. Okay, you have to use some different instrument or appliances for that. Okay, and now coming to the suspension that can be filtered. We have discussed that. So why do colloids and suspensions scatter light? The Tyndall effect, which we were talking about. So this I have again already, explained this, that it's like the scattering of light by tiny particles in colloidal and suspension mixture. Okay, so what is basically happening? There are tiny particles and the light just come through it and gets scattered in different directions because it hit it. Okay, but it is not, big enough to make a shadow or something. So it's just scattering the light. Okay, it is unable to block the light. It is just scattering the light in different direction. So examples of Tyndall effect would be the dazzling glow of fog lit by car headlights. So if you have, in winters, if you are going through a, through a drive, you will see that the fog, will be lit by the car headlights. Okay, and it will look very pretty. Now, sunlight creating visible shafts as it passes through the dense trees. If you will ever go to a forest or maybe, a national parks or something, or so there where the dense trees are there, the big trees are there. Okay, through that you will see the light, coming like this. Or maybe in images or, movies, you might have noticed, right? And you might also be able to see dust particles also, right? So that is also because of colloid, okay? And that is a colloidal kind of example, you can say. Seeing dust particles dancing in a sunbeam in a dark room. So if you open a window small, or maybe a hole is there in your window, and So you will see the sunbeam coming, and from there you will be able to see the particles, small dust particles, right? Okay, so these all are example of colloids. Okay, quiz time again. So here, first question would be, muddy water is it a solution? Is it a colloid? Is it a suspension? Now, I am sure you'll be able to answer this by now. Which mixture does not show the Tyndall effect? Is it a salt water? Is it milk? Is it fog? So just let me see how many of those you got the concept. Try answering these, okay, in the comment box. Which method separates colloids? Is it filtration? Is it centrifugation? Okay, so let's see who understood the lesson better. Okay, I hope everybody understood it better. Okay, so thank you so much for joining the session. Hope to see you soon in the next session. And you can try, finding out one suspension and one colloid and maybe answer it later to us. Thank you so much, and contact me through my Urban Pro profile if you want to check out more sessions. Okay, thank you. Bye-bye. Take care.